Now we are discussing three laws of the Kepler. First law, the law of orbits. Kepler told all the planets move in elliptical orbits and the Sun is situated at one of the foci of the ellipse. See, this is the elliptical orbit. The planets are revolving in this elliptical orbit and the Sun is located at the one of the foci. Example, if Earth is the planet that is revolving around the Sun, if the Earth is near to Sun, if the Sun is at this focus, then we experience the summer season. If the Sun is far away, if the Sun is located at this second focus, then we experience the winter season. So the Sun situated at one focus is calling one season. Another focus, the situation of the Sun in another, the position of the Sun in another focus is calling the another season. So the position of the Sun in the two focuses, the changing of the position of the Sun in two focuses, that is causing the difference in the seasons. Okay, this was the statement from the Johannes Kepler. But this law was a deviation from the Copernican model. Why? Because Nicolaus Copernicus said the planets revolve around the Sun. There is no wrong in it. But the problem is, he mentioned the planets revolve around the Sun in the circular orbits. But now Kepler came and said, no. The planets revolve around the Sun, but they revolve in the elliptical orbits. Now here we are taking 2 points F1 and F2. So this is F1 and this is F2. This time we are taking a small string. And one point of the string is fixed at F1 and second point of the string is fixed at F2. And this string, another end we have tilted and we called that one as T. This T is touching the ellipse. Now, if we calculate the distance between T and F1, if we call this distance as A, and T to F2, if we call this distance as B, summation of these two distance example is it gives 10. If we shift the T from this point to another point, at that time also the summation of the distances from T to F1 and T to F2 remains constant and the value will be 10 only. So irrespective of the position of the T, the TF1 and plus TF2 remains constant. Now if we extend this straight line which is joining the 2 points F1 and F2 onto the ellipse, then the intersection we observe, the right side intersection is A and the left side intersection is P. So we have 2 points P and A. Now this PA, the center of this PA is nothing but the center of the ellipse. And the PO is called semi-major axis and AO is called semi-major axis. PO and AO are both are equal. In order to make the ellipse as a circle, these two focuses, F1 and F2, these two foci have to merge into the center of the ellipse, then it will become the circle and the semi-major axis will become the radius of the circle.